All right, today we're going to look under the hood of our food supply. We're exploring some really fascinating tech that basically gives us a direct window into the health of a plant, and it's changing how we think about growing the food we eat. Okay, let's dive right in. So, picture this. You're in the grocery store, you pick up this beautiful looking carrot or maybe a perfect head of lettuce. You buy it because, hey, it's healthy, right? But is it? I mean, how much nutrition is actually packed inside? Well, the surprising answer is it's kind of like playing the lottery. And we're not talking about a small difference here. A report from the Bionutrient Institute looked at a whole range of crops and found these massive inconsistencies. Get this. They found that to get the same amount of certain nutrients, you might have to eat 3 carrots from one farm or just one from another. But here's where it gets truly staggering. In something called plant secondary metabolates. Now, that's just a fancy term for all the good stuff, compounds like antioxidants and polyphenols that are so important for our health. Between the least and the most nutritious crops they tested, the difference wasn't 10% or 20%. It was a mind-blowing 1,400%. So this begs a really important question. Why? Why is this happening? Why is our food so inconsistent? Well, the answer actually lies in the tools we've been using to measure a plant's health this whole time. And here we are at the fundamental flaw in how we've been doing things. For decades, the main focus has been on testing the soil. But there's this huge disconnect. Just because a nutrient is physically there in the dirt or even in the water, that doesn't mean the plant can actually grab it and use it. And that leads to some pretty serious limitations. Even if you test the plant's dry leaves, you're only seeing what it is stored up, not what it's actively using right now. Plus, get this, the optimal levels that farmers are aiming for, a lot of that is based on old data that was all about maximizing yield, the size and weight of the crop, not its nutritional density, or its ability to actually fight off disease. To really get a sense of the complexity, take a look at this. It's called the Mulder chart, and it basically reveals this hidden web of interactions. Every line shows how one nutrient affects another. Too much of one can literally block the plant from absorbing a different one. It's this incredibly delicate balancing act that traditional soil tests just completely miss. So if the old way of testing is broken, what's the solution? I mean, clearly, we need a way to see what's happening inside the plant in real time. What we need is the equivalent of a blood test.
And that is exactly what plant sap analysis is. Instead of testing the soil or dried out leaves, it analyzes the sap itself, the actual fluid moving through the plant's veins. This shows us precisely which nutrients are being absorbed and transported at that very moment.
The analogy is just perfect, isn't it? It's a real-time diagnostic that gives us a snapshot of the plant's metabolic health, and it can reveal shortages or excesses way before they ever become a problem you can see with your eyes. And the process itself is pretty straightforward. You take samples from both the new growth, the young leaves, and the older, more established leaves. From those leaves, the pure sap is extracted and then it's sent off to a lab where it's analyzed for a whole spectrum of different nutrients and minerals. Now, the reason for sampling both young and old leaves is actually the secret sauce. See, some minerals, like nitrogen, are mobile. The plant can move them from old leaves to new growth when it needs to. But others, like calcium, are basically stuck where they are. So by comparing the two samples, we get this incredibly clear picture of how nutrients are actually flowing through the plant. Okay, so the science is cool, right? But what does this actually look like in the real world? Let's check out a couple of case studies to see the kind of impact we're talking about. First up, strawberries. Now, we have 2 different varieties of plants here, but they're in the same field, getting the same exact soil and the same fertilizer. The conditions are, for all intensive purposes, identical. And yet, look at this. The results couldn't be more different. One group is healthy, it's thriving. The other one is getting absolutely devastated by powdery mildew, which is a really common fungal disease. So what did the sap analysis show? Well, the key difference was silicon, which you can see marked as Si on this chart. The healthy plants had way higher levels of silicon in their sap. So why does that matter? Well, silicon helps build stronger cell walls, and that creates a physical barrier that makes it much, much harder for fungal diseases to get a foothold. All right, now let's look at a commercial lettuce operation. Here, the goal isn't just about plant health, it's also about efficiency and, of course, profitability. This facility started using sap analysis to really fine-tune their entire nutrient program. The results were immediate and, frankly, dramatic. In just the first year of using sap analysis, they managed a 27% decrease in the time it took to grow a crop to harvest. For a commercial operation, that is a total game changer. It means more crop cycles, more revenue from the exact same space. But it wasn't just about speed. Optimizing the plant's nutrition created much healthier, more resilient crops. They were better able to resist pests and disease, which led to an incredible 89% reduction in crop waste from spoilage. Just think about that. So, the financial impact of growing faster and wasting less? It was stunning. It all translated to a 49% increase in annual revenue and profit. That's a massive return, and it was driven entirely by just having a clearer picture of plant nutrition. And just to show you how versatile this approach is, let's look at one last example, a high-value cannabis crop. By applying these exact same principles, this small high-value operation was able to perfectly dial in their nutrient mix. The result? An absolutely staggering 117% increase in annual revenue. They more than doubled their income. It's just a powerful testament to what precision nutrition can do. You know, it all comes back to this one simple but really powerful idea. For so long, growing food has involved a ton of guesswork. But with tools like SAP analysis, we can finally move from guessing to knowing. And that leaves us with a pretty fascinating question for the future, doesn't it? What if the food in our grocery stores was no longer a nutritional lottery? What if every single carrot, every strawberry was grown to its absolute full potential? It could change not just our farms, but our own health as well.